Everybody says Kimi K2.7 is the budget coding model that punches way above its price. I spent the last week stress testing every bold claim Moonshot made, and some of them don't hold up. Kimi K2.7 claims near flagship coding at a fraction of the cost, so the real question is simple. Do those claims actually survive contact with real numbers? Claim 1, benchmark parity with GPT 5.5. The objection I keep hearing is, if Kimi K2.7 is actually hitting 87 to 99% of GPT 5.5 scores, why are people still paying flagship prices? And a gap on the wrong benchmark could mean your coding agent ships broken output on a Friday, and you're the one debugging it all weekend. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. I went through Moonshot's own benchmark table, and on 5 of 6 tests, K2.7 code lands between 87 and 99% of GPT 5.5 scores. That's mostly real, though it's vendor data, so no independent lab has confirmed those exact ratios. Program Bench is the weak spot, a 22-point gap at 77.6%, which is the one place the parity story wobbles. Goldie Bench independently scores K2.7 at 7.46 out of 10, but I couldn't find a direct GPT 5.5 head-to-head there. Charge 1 holds up, at least directionally. Vendor benchmarks are consistent and Goldie's independent score is solid, even if no outside lab has run the full head-to-head. The parity claim is vendor-backed, not vaporware, and that's one of one charges holding up so far. I know that vendor-only data because I've been living inside these tools long enough to spot a benchmark table with no independent backup. Drop a comment below if you've run K2.7 on your own codebase and got a different result. Claim 2, cost per task versus DeepSeek. Moonshot's marketing basically says you'll spend under $1 per task, which sounds like a steal. But run a few hundred coding tasks a day at that rate, and your bill is already hundreds of dollars. And if the real number is way higher, you've built your whole cost model on a fiction. When I dug into the community measurements, the claimed 0.87 figure had zero sourced backing, and real-world data puts K2.7 at roughly 0.31 per task. That sounds cheaper until you see DeepSeek V4 Flash sitting at about 0.03 per task, so K2.7 is still around 10 times more expensive per task. And on raw per token pricing, it's 6.8 to 14 times higher, depending on input versus output. Charge 2 sticks hard, that cost claim is flat out unsupported, and the real per task gap versus DeepSeek is roughly 10 times, which is a number that compounds fast at scale. That's one of 2 charges holding up now, and the cost narrative is the one that matters most to anyone building at scale. Claim 3, 30% fewer thinking tokens versus K2.6. 30% is a lot. If you're running an agentic loop that fires 100 reasoning steps a day, that token bloat adds up fast and shows up directly on your invoice. So the question is whether this efficiency number is actually real or just a press release. I didn't expect 3 independent sources to line up this cleanly, but Moonshot's official page, Cloudflare's changelog, and VentureBeat all report the same roughly 30% thinking token reduction versus K2.6. Cloudflare's changelog is the one that really nails it down as an independent confirmation. VentureBeat does note practitioners are skeptical whether the gain holds on their specific benchmarks, so it's confirmed in principle, but your real-world mileage on a particular codebase may vary. Charge 3 is dismissed. The 30% thinking token cut is the most credibly sourced claim in this whole review, backed by vendor, independent changelog, and press all citing the same number. That's 2 of 3 charges holding up, and this one's the cleanest win Kimi K2.7 has. Alright, so 2 more claims to go, and the next one is the code review precision stat, which is the number Moonshot uses to justify why K2.7 is worth the premium over cheaper models. If that stat doesn't hold up, the whole value proposition for production coding falls apart, and the last claim on agentic gains could be the only thing saving it. Claim 4, code review precision at 55% versus DeepSeek's 48%. The day your code review tool misses a critical bug because its precision number was marketing copy is a bad day. A 7-point precision edge sounds modest, but in a production pipeline reviewing hundreds of pull requests, that gap is the difference between catching issues and shipping them. I ran this one twice because I couldn't find the 55% precision figure anywhere. It has no source at all, 0, completely unsupported. What LM speed actually shows is K2.7 ahead on code scoring at 58.4 versus 50.7, and on agents at 54.1 versus 50.4, which is a real directional lead, but no precision or recall breakdown exists for either model in any published data I could find. Charge 4 sticks, the 55% precision claim is a fabricated sounding stat with no backing anywhere, and putting a made-up number out as a product differentiator is a real problem. That's 2 of 4 charges holding up, and this one's the most damaging because it's the number people would use to justify paying the premium. Claim 5, roughly 10% agentic performance gain over K2.6. The concrete consequence is this: if you're running autonomous agents doing multi-step coding tasks, and your model stalls or backtracks, more than the previous version, you're burning time and tokens on every single loop. A real 10% improvement on agent benchmarks would actually move the needle on that. Pull the actual numbers and it gets pretty interesting. Kimi K2.7 went from 42.9 to 46.9, a 9.3% gain. MCP Atlas went from 69.4 to 76.0, plus 9.5%, and MCP Mark Verified went from 72.8 to 81.1, plus 11.4%. IJA independently confirmed the roughly 10% figure matching Moonshot's own data, which is the kind of cross-source agreement that makes a claim credible. Charge 5 is dismissed. The agentic gain claim is the best evidenced one in this whole review. Concrete numbers across 3 benchmarks with independent press confirmation. That's 3 of 5 charges holding up, and the final tally is what decides whether the upgrade is actually worth it. Okay, so where does Kimi K2.7 actually shine? The benchmark parity with GPT 5.5 is vendor-backed on 5 of 6 tests and not vaporware. The 30% thinking token reduction is confirmed by Moonshot, Cloudflare, and VentureBeat. That's a real efficiency win. And the agentic gains of plus 9.3 to plus 11.4% over K2.6 are concrete, independently echoed numbers. And where does it fall short? The cost per task claim is flat out unsupported, and real community measurements put it at $0.31, which is still about 10 times DeepSeek v4 Flash's $0.03. The 55% code review precision figure doesn't exist in any source I could find, and users report the 5-hour usage limit burns in 30 minutes, with instruction following that feels worse than Claude or ChatGPT despite the benchmark scores. 3 of 5 charges hold up. Worth it if you're doing light writing or agentic experiments where the token efficiency matters. Skip it if you're building production coding pipelines where that 10 times cost gap versus DeepSeek compounds fast. The safer pick for serious coding is still the more expensive, more reliable option, because the benchmark to reality gap is real, and the 5-hour limit hits sooner than you'd think. Moonshot doesn't put this in the headline. The 5-hour usage limit is a hard cap, and users report hitting it in under 30 minutes on real coding sessions. There's no warning before it cuts you off, so if you're mid-task on something production critical, you lose context and continuity with 0 notice. Alright, so if the cost per task math is what matters to you, the next logical question is how K2.7 stacks up head-to-head on price against its closest budget rival. I've got that breakdown in the video DeepSeek v4 Flash versus Kimi K3, which is cheaper, and it's worth watching before you commit to either one at scale.